Hi students, so today I'm going to discuss the entrance test 2 of Eklavya. I'm going to discuss the physics subject and this test happened on September 29, 2024 and let's get on with it. So the first question that you had in the paper, it read, a square loop carrying a current I is kept in the xz plane with its center at the origin and the sides parallel to the x and the z axis. A long wire carrying the same current I is placed parallel to the z axis, okay, and passing through the point 0 b 0. Select the most appropriate. So first of all guys, you have not been given the figure in this question, so you need to really read the question carefully and then you need to make the figure. This is an important aspect of problem solving where you have to understand the language given in the question and you have to comprehend the situation. All right, so according to this situation, we should draw, like, the usual way of drawing the axis is this. The usual way is that we just a minute guys, I think color, yeah. So we draw x-axis like this and generally we draw y-axis like this, okay, and we consider the z-axis, like this. Okay, so according to this figure, if I want to draw the square, okay, then the square should be drawn like this because the square is having its center. The square is having its center at the origin of coordinates, and the sides of the square, they are parallel to the x and the z axis as it was mentioned in the question. So the question says that the center is at origin and sides are parallel to x and z. So using these information, I think we can uniquely identify that the square was kept like this. And also it says that there is a current carrying wire I. There is a current carrying wire. The current is I, and it is parallel to the z-axis, and it is passing through the point 0 b 0. So again, we can uniquely draw the current carrying wire. So the current carrying wire would appear somewhat like this. So it would be parallel to z-axis, and it will pass through the point 0 b 0. So this height would be b. We know that this height would be b. The distance of the wire from the center of the square would be b. Okay, so this is the situation now. The direction of the current is not given to us. We can consider it to be in any direction. And now we have to actually talk about the force and the torque. So the options talk about the net force on the square loop. All right. Yeah. So all the four options, they are talking about the net force on the square loop, and non-zero along y-axis, non-zero along z-axis, 0. So basically, when I read the four options, what I understand is that I have to imagine what will be the direction of the net force acting on this square loop. And if it is 0, then there is no question of direction. Then straight away option C would be correct. So let's start doing this. So guys, in this situation, what I understand is that there is a current carrying wire, and then we have four wires. We have four rods or wires. You can say whatever you like, and we have to talk about the force on each of these four wires. Okay. Two of these wires, they are parallel to the given wire. Let me call this as one. Like, let me number them. Okay, so let's say this is 1, let's say this is 2. All right, so 1 and 2, they are parallel to the given wire. All right, notice this, that they are parallel to the given wire. This line is parallel to z-axis, this is parallel to z-axis, so they are parallel to each other. Similarly, this is parallel to z-axis, so they are parallel to each other. All right, and we know that when two wires are parallel to each other and they are both carrying current, okay, they are both carrying current, then they attract. And if they are both carrying current in the same direction, then they attract, and if the direction is opposite, then they repel each other. One thing, let's just check whether the square has current in it or not. So square loop carrying a current I, okay, so the current is there. The wire also has the same current, so definitely there would be magnetic force. All right, and I understand that if I assume the current in this square loop in this branch to be flowing like this, then the current in other branches, they are automatically decided. So if branch 1 carries the current in the same direction as the given wire, then branch 1 would be attracted towards the wire. Okay, so I can draw an arrow like this. What is the rule I'm using here? That parallel currents attract each other. Okay, and this wire will repel. This wire will repel the branch 2. Okay, this will repel the branch 2. So we have talked about 1 and 2. All right, and if I draw a figure such that a person is viewing from the z-axis, let's say if the same figure is being viewed from the z-axis, then what kind of figure are we going to get? So x-axis will appear like this, y-axis will appear like this. Okay, I'll draw the square loop in yellow color. All right, so this is how the square loop will appear. Of course, let's say this is A, this edge or this vertex is B, this is C, and this is D. So A and B will be visible to us. D will be behind A and C will be behind B. So that would be the situation. And the current in AB branch the current in the AB branch would be leftward. The current in AB branch would be leftward. The current in DA branch would be outward. So let me draw a dot here. So this dot indicates the current in the DA branch. The current in the BC branch would be inward. So let me draw a cross here. So this cross indicates the current in the BC branch. This is the situation, and this wire, this current carrying wire, which I have drawn in red color. Let me draw a dot here. So this indicates the current carrying wire, and this current carrying wire is attracting branch 1. It is attracting branch 1. Branch 1 is the branch AD. So this is the force that we are getting. Okay, and it is repelling. It is repelling this branch. So the force that we will get would be like this. So this force and this force, they are expected to be same in magnitude, but the directions would be like this. Now, if we talk about the CD branch or the BA branch, we have to talk about these branches separately. These branches are in skew position. Skew position. So what does that mean? Let me draw it on another slide. So this wire, the given current carrying wire of infinite length is like this, and the branches are like if I draw let's say CD branch. If I draw CD branch, then it would be like this. The CD branch would be like this. Okay, the CD branch would be like this. Where current in this branch going in this direction. All right, this is C, this is D. Now understand this. This wire will have magnetic field lines going like this. This wire will have magnetic field lines like this. Okay. So if I divide the CD branch into segments, all right, I'm drawing few segments, but you can definitely make more segments. Then notice that this segment will have a current towards right, and it is experiencing a magnetic field in this direction. All right, so magnetic field is the component of magnetic field perpendicular to the current carrying element is this. Okay, so magnetic field is downward and current is rightward, so the force would be inward. So this element would be experiencing a force inward. Okay, but if I check a similar element here, the direction of magnetic field is not same as this. The magnetic field was here. In this case, the magnetic field was here. So the direction of the perpendicular component of the magnetic field reverses. Here the perpendicular component of the magnetic field was downward. Here it becomes upward. The current is still in the same direction. So magnetic field is upward, current is this direction. So the force is outward. So this branch experiencing an outward force. All right, or this particular segment. All right, so any segment which experiences the force inward, corresponding to that, there would be another segment which would be experiencing a force in the outward direction, and therefore the two forces are going to cancel each other, and therefore this branch will have a net zero force. Will there be torque? Yes, this kind of forces, they will definitely produce a torque. But if I come to this figure, what exactly is happening? So we have considered the CD branch, and we concluded that the portions towards C will experiencing an inward force. So let me draw it here. So this portion is experiencing a force like this, which is decreasing, which becomes zero, and then this portion is experiencing a force in this direction. So this is what is happening. So net force is zero. All right, but if I come to this AB branch, so in AB branch the current is in opposite direction. So what happens here is that the force on this branch will be in the opposite direction. So we get force like this. So now imagine what is happening. So these two branches, all right, individually both these branches are having zero force, but when we consider the torque on this and the torque on this, they combine to give us the zero torque. So as far as the role of CD branch and AB branch is concerned, they are not contributing to net force, they are not contributing to net torque. So the decision that we want to make, it will depend only on these two branches. And when I look at these two branches, all right, I realize that the net force will not be zero, even the net torque will not be zero, because these two forces are definitely going to produce an anti-clockwise torque as seen in this figure. All right, and the net force will be in this direction. You can see that this force will have a component in this direction. This force will also have a component in this direction. These two components are going to get added up. The other components are going to get cancelled. All right, so these components are going to cancel. In fact, these components will be responsible for the torque, and these components will be responsible for the net force. And the net force we are getting, we are getting parallel to x-axis. Note that this is x-axis, so we are getting parallel to x-axis. The exact direction of the current in the wire and the current in the square loop was not given to us. So while we can't be sure that the force will be definitely in the negative x direction, we can be sure that it will be parallel to x-axis, either positive I or negative I. All right, and also the force is not zero, the torque is non-zero. All right, so now let's check the option. So the option says the net force on the square loop is non-zero and along y-axis. so this becomes wrong. The net force on the square loop is non-zero and along z-axis, this becomes wrong. The net force on the square is 0, this becomes wrong. The net force on the square loop is non-zero and is along x direction, so this option becomes right. So the first question will have option D as the correct one. All right. So if you have understood everything that I've explained here, then I would say that the question would have served its purpose. The purpose was to actually teach you about the different scenarios, that we can come across. Straight wire carrying current, it can have other wires surrounding it. So actually, this question takes care of all the situations that are there. All right. So good question. All right. We got the answer. Now let's go to the next question. Okay. So this is question number 2 that you got in the test. So capacitors of capacitances 3C and 6C are charged to a potential difference 2V and V. Okay. Respectively. These are then connected in parallel such that in such a manner that the positive terminal of the one is connected to the negative terminal of the other. So guys, the moment you actually start making this diagram corresponding to this question, I think the question would become very easy. So there is a capacitor, the value of which is 3C, and it has been charged to a potential of 2V. So let's say the charge that will be there, it will be like, let's say, plus 6 C charge. Okay, it's 2V or 2 volts, so 6 CV and minus 6 CV. The other capacitor has a capacitance of 6C and it has been charged to a potential of V. All right, so here minus 6V and CV actually. All right, and here plus 6 CV. Now when we connect them parallelly, so parallel connection means that such that the question also says that the positive terminal of one is connected to the negative terminal of the other. All right, the final. So when we do that, what happens is that the total charge on these two plates that gets divided in a certain ratio. All right, but the thing is that the total charge is 0. So whatever that ratio is, it's immaterial. What would have happened if these two number wouldn't have given a 0? What would have happened then? Let me tell you that. Although the answer is 0, we have already discovered that the answer is 0. But in case if these two numbers were not equal, then what would have happened? Then we would add these two numbers. Let me write it as Q1. Let me write it as Q2. You add these two numbers and then they get divided in the two capacitors. And because they are connected in such a manner that the potential difference across the one should be same as the potential difference across the other. And if we check from Q is equals to CV, if V is same, then charge gets divided in proportion to the capacitance. So the 3C will get lower charge and the 6C will get more charge. What would be the ratio? It would be 3 divided by 3 plus 6. All right, so this much charge will appear on this plate. All right, and this plate will get a charge of Q1 plus Q2 into 6 by 9. So this much charge will appear here. All right. Yep. So the potential difference will be same. Yeah. So this is what would have happened. But in this present case, Q1 plus Q2, they add up to give a 0, and therefore the answer to this question would be 0. And we need not worry about the ratio of the capacitances. All right. We'll go to the question number 3 now. Question number 3 says that a galvanometer of resistance G. I hope you are able to read the question. Yes, it is readable. A galvanometer of resistance G is converted into a voltmeter of range 0 to 3 volt by connecting a resistance R1 in series with it. The additional resistance that should be connected in series with R1 to increase the range to 0 to 8 will be okay. So we have a galvanometer and this galvanometer already has some resistance. Okay, the resistance of the galvanometer is G. Okay, and we have converted it into a voltmeter. So this galvanometer can tolerate a certain amount of current. Let me write it as I max. So this is the maximum current that the galvanometer can tolerate. If we try to pass more current through the galvanometer, it will get damaged. Okay, now we connected a resistance in series with it. Let's say this resistance was R1, and what we were hoping by doing that was that once the potential difference between these 2 points becomes 3 volt, only then there is a current I max flowing in this circuit. Okay, which basically means that I max would be equal to 3 volt divided by G plus R1. This is G actually. Okay, so this would be my first equation. Now the question says that how much the additional resistance that should be connected in series with R1. So we want to connect one more resistance. Let's call it as X. And our idea is that after connecting X, the range will become, or the voltmeter will it can then measure up to 8 volt. So now the equation will become that I max is equals to 8 divided by G plus R1 plus X. All right. So we will equate these two, and by equating these two and then solving, we can get the value of x. All right. So because I know I want to get the value of x, let me equate the inverse of these two ratio. All right. So that will be easier for me. Let's do it on the next page. Okay. So we will say that g plus r1 by 3 is equals to r1 plus g plus x by 8. We want to get the value of x. So 8 by 3 minus 1. Okay, 8 goes there. So 8 by 3 minus 8, r1 plus g. That should be the value of x. I hope I have solved it correctly. So this will become 5 by 3 times of r1 plus g. That should give you the value of x. So do we have an option like this? 5 by 3 r1 plus g. Option D is there. So option D should be the correct one. And we can check it here. So option D is indeed the correct one. So that was question number 3 for you, everyone. All right. Now we'll go to question number 4. Okay. So question number 4. This question says a solid sphere of radius r has a uniform density rho. If a sphere of radius r by 2 concentric with the original sphere is given some extra charge, so that the total charge density for the spherical region for this spherical region, all right, is 4 rho, then find the electric field. So guys, ultimately what is the situation here? So this figure I'll draw it. So we have a sphere of radius r, and this sphere had some charge in it such that the density was rho, all right, and it had a radius of r. It had a radius r. Okay. Then what we did, we provided some extra charge to the region of radius r by 2 such that the density, the overall density there became 4 rho. Now we want to know the electric field on the surface of this sphere. So guys, if that is the situation, like if the charge is distributed radially symmetrically, all right, like it is symmetric about a point, if the charge is distributed radially symmetrically, and we are trying to find out electric field at any point which is outside this charge, then the total charge will play a role in determining the electric field at A. For example, if I'm trying to write electric field at A, it would simply be K into total charge by R square. So I just need to find the total charge. All right, let's do that. So EA will be written as K. Let me write K as 1 by 4 pi epsilon naught, because I've already noticed that the options are in terms of epsilon naught and not K. All right, and then R square also, let's write it here. And now we want to write the total charge. How we will write the total charge? So rho will be multiplied with the outer volume. The outer volume would be 4 by 3 pi r cube minus 4 by 3 pi r by 2 cube. All right. This is the charge in the green region that we have written. Now the charge in this region, for that the density is 4 rho and the volume is 4 by 3 pi r by 2 cube. So doing this calculation will give us the answer. Now we have to just finish the calculation. All right, to finish the calculation, what we can do, let me do it on the next page. So it would be 1 by 4 pi epsilon naught r square, and we'll pull out 4 by 3 pi r cube as the common quantity because that was present in all the terms. All right, in fact, we can pull out rho also. Okay, so this rho 4 by 3 pi r cube, this is 1 minus 1 by 8. So we will get 1 minus 1 by 8. Okay, and then what? So this is 1 minus 1 by 8 plus this will become 1 by 8 and 4 is also there, so half. Okay, so plus half. And now we will calculate this. Also notice that few things are getting cancelled here also. For example, this 4 pi goes with 4 pi, r square goes with r square. So here we are left with rho r by 3 epsilon naught. On the outside this has happened, and on the inside we can take 8 as the LCM, and then it becomes 8 minus 1 plus 4. All right, so we ultimately get rho r by 3 epsilon naught into 12 minus 1 is 11, 11 by 8. All right, so it ultimately becomes 11 by 24 rho r by epsilon naught. Let's check whether we have an option like that or not. Okay, we went to the previous question. 11 by 24 rho r by epsilon naught, option number D. Okay, so D option is the right one for this question. All right, students, we'll go to the next question now. That would be question number 5. Okay. Two concentric spherical shells are given positive charges. So there are two concentric spherical shells and we have given them positive charges. It is not said whether the charges are equal or unequal. Okay. So two concentric spherical shells are given at the outer shell will be at higher potential. The inner shell will be at higher potential. Outer shell will always be at higher potential irrespective of the sign of the charges given to the two spheres. Okay, no prediction can be made. So guys, in this case, if this shell has positive charge, if this shell has positive charge, two concentric spherical shell, the question doesn't say whether we have given provided them uniform charges or non-uniform charges. The question also doesn't say whether the shells are conducting or not conducting. But if there is a positive charge on this shell, all right, then we can expect that the electric field lines will go out of this shell, all right, and therefore as you move from this shell to the outer shell, all right, the potential will decrease. Okay, the potential will decrease and therefore the inner shell should be at a higher potential. So option B should be correct here. The option B, that should be correct here, and that is actually correct here. uh, is that okay, everyone? Okay, all right. Okay, now question number 6. Okay, uh, yeah, before we do that, I want to, all right. Question number 6 is a point charge Q is located at the center of a hollow spherical conductor. Hollow spherical conductor having inner radius as R1 and outer radius at the center. The conductor being uncharged initially, the potential at the inner surface will be, all right. So the situation is this: we have a conductor like this. So this radius is R1, this radius is R2, and this conductor is not charged. So this region is solid. It is made up of, let's say, a metal. Okay, and what we have done, we have kept a charge at the center. Okay, we have kept a charge at the center. What happens is that there will be negative charge induced here. Okay, this surface will have positive charge. Okay, let's say this is minus Q, let's say this is plus Q. Now we want to know the potential at the inner surface. What we do, we write potential due to all the charges that are present in the vicinity. So potential at the inner surface will be written as uh, KQ by R2. That's the contribution from this surface. Okay, minus KQ by R1. That's the contribution from this surface. And then plus KQ by R1 again. That's the contribution from this point charge. These two gets cancelled. So the answer is KQ by R2. So none of these is the correct one. All right, none of these is the correct one. So, I think we try to play with your mind because generally people do not go with none of these. This is a topic where the students are generally very doubtful about what they are thinking, like whether their thought process is correct or not. And if they don't find what they get as answer in the options, they find it very reluctant to actually go with none of these. And if you found one of these as your answer, then obviously you're going for the wrong one. So it's more like instead of electrostats, it's more like playing with your mind. I used a topic in which you guys face difficulty, and that is the induction in conductors. And I tried to give you none of these as the answer so that you keep on doubting yourself. Okay, now question number 7. Technician has only two resistance coils. By using them singly or in series or in parallel, he is able to obtain resistance of 4, 6, 12, and 18. The resistance of the two coils are. All right, now guys, this is actually a very easy question. Like, we are allowed to use the coil singly or in combination with the other. So in that case, see, the least amount of resistance will happen when you are using the two in parallel combination. So the out of these four number, the least is 4. So we can be very sure that R1 R2 upon R1 plus R2, this should be 4. And the maximum you're going to get, you get that when R1 like when the resistances are in series. So this should, which basically means that these two should be R1 or R2. Like one of them should be R1 and the other is R2. Now the only thing that you might want to check, again, you need not check it because we don't have none of these here in this option, but there could have been an option none of these. So just to rule that out, I will check whether that given data is consistent or not, because if none of these is there, then it might just happen that the given data is inconsistent. So if I substitute 6 and 12 in these equations, do they match? So this equation certainly matches, and if I substitute here 6 into 12 by 18, So even this matches. So the resistance are 6 and 12. So as you can see that we were not really required to do any kind of calculation to get answer to this question. All right. Now comes question number 8. Okay, a potentiometer of wire length, a potentiometer wire of length L and resistance 20 ohm is connected in series with a battery of EMF 5 volt and resistance R in the primary circuit of the potentiometer. If a cell of EMF gets balanced, then what is the value? Again, guys, this is it's a standard question of potentiometer, but the point is that most of the students struggle with the potentiometer, especially when the diagram is not given. So now you have to read the question, you have to make the diagram, and you have to solve it. That's too daunting for a student who is writing Eklavya entrance test. All right. Let's try to do this. So a potentiometer of wire of length L. So let's say this is a wire and the length of this is L. Okay. And resistance 20 ohm. So the resistance of this wire is 20 ohm. All right. It's connected in series with a battery of EMF 5 volt. All right. So let's connect it in series with a battery of 5 volt EMF and resistance R in the primary circuit of the potentiometer. Okay. So we have connected a resistance to the value of this resistance is R. If a cell of EMF 1 volt, so we have used a cell of 1 volt, and it says that it gets balanced at the length L by 4. So it gets balanced at the length of L by 4. All right. Then the value of R is. So we want to know how much this resistance is. So guys, what we understand from here is that in a length L by 4, the potential drop is 1 volt. All right. So the entire potential drop across the wire, for example, if I say this is point A and if I say this is point B, then VA minus VB, which is actually L, which is 4 times the L by 4 length. So can I say that this is 4 volt? Because in L by 4, there was a potential drop of 1 volt. So in 4 times the length, there would be a potential drop of 4 times. So the potential difference across this is what? It is 4 volt. All right. Which basically means that the potential difference across this is 1 volt, because in the entire circuit, the potential drop should be of 5 volt. Like as we move from this point and we reach this point, there should be a total drop of 5 volt. All right. So 4 volt here and then 1 volt here. Okay. So this is what we are getting. And if there is a potential drop of 4 volt in a resistance of 20 ohm, then we can certainly say that the current flowing through this wire is 4 by 20. How much is that? 4 by 20, is it 0.2 ampere? So if the current is 0.02 ampere, if the resistance value is that is unknown, voltage drop is 1. So how can we get the resistance? We can get the resistance as voltage drop divided by the current in the circuit. So that would be 5 ohm. So the value of this resistance would be 5 ohm. So option A would be the correct answer. Is that okay, everyone? So this is how we can solve this question. Again, if you know potentiometer, if you know the theory, then it's an easy question. If you don't know, then it's a very intimidating question. Okay, now the question says, question number 9. It says in a certain region, uniform electric field E and magnetic field, uniform electric field E and magnetic field B are present in the opposite direction. Okay, at the instant t equal to 0. At the instant t equal to 0, a particle of mass m carrying a charge q is given a velocity v naught at an angle theta with the y-axis. The axes are depicted in the diagram. Okay, in the yz plane. All right. The speed of the particle after this particular time would be. Now that's a very tricky question, guys. That's actually a tricky question. So what we have to understand here is that the time given to us is a kind of peculiar. So that might be a hint. Let's try to understand what would happen here. So to understand that, you can start by thinking that what if this electric field was not present here? What if it was not there? If this electric field wouldn't have been there, then the situation would have been that we provided a velocity making some angle with the magnetic field. All right. So in this case, the particle begins to move on a helical trajectory, right? In this case, what would have happened? The magnetic field is towards z direction, y direction is outward. So magnetic field is in this direction, v perpendicular is in this direction. So the particle will start making circles like this, and it will also keep on traveling along the magnetic field. So we can expect a helical motion like this. Okay, if we are viewing from the z-axis, if we are viewing from the z-axis, upward will be x-axis, leftward would be y-axis. The particle was given a velocity from the origin. All right, so the particle was given a velocity from the origin. Just a minute, guys. So magnetic field is in this direction, velocity is in this direction. So the particle, the helix would appear like this, like a circle like this. So it's coming, it's like this, it's coming out. All right. Now understand that if the electric field is present, like if it is present in the negative z direction, so in this figure, the electric field goes into the screen. Okay, so if the electric field is going into the screen, then the particle which is coming out, which will keep on slowing down, and then it will start moving along the electric field. So it will come out like this, and then it will continue to move it will continue to rotate in the same direction, but it will start going inside. All right, because the electric field would be actually reducing the z component of the velocity. How much acceleration in the z direction the electric field can cause? How much acceleration it can cause? That would be charge into electric field by m. All right, and this is the time. So this component of velocity would have been v naught cos theta, and this component of velocity would have been v naught sin theta. All right, so I can clearly see that this acceleration multiplied by time, okay, this time, okay, the given time. So this multiplied with the given time gives us what? If I multiply it with the given time, okay, this gets cancelled, this gets cancelled, we get v naught sin theta, which basically means that at this particular time the z component of the velocity became 0. The z component of velocity was outward, electric field is acting inward direction, it is reducing that, and the product of acceleration and the time becomes equal to the z component of the velocity. So that velocity would have just become 0. So the only velocity left with the particle would have been v naught sin theta at this particular time. All right, so the particle is turning like this, and the very moment when the z component of the velocity becomes 0, that time is this time. All right, and after that it will start having a z component of velocity in the negative z direction, so the particle will start going in. So the question asks the speed of the particle after this much time. The answer would be v naught sin theta. All right, the answer would be simple, v naught sin theta. I'm sorry, v naught cos theta. Yeah, v naught sin theta will become 0. V naught sin theta will become 0. The leftover velocity would be v naught cos theta. Yeah, the leftover velocity would be v naught cos theta. So that is question number 9 for you. Okay. Now let's go to question number 10. Okay. So this question says the conductor ABCDE, okay, carries a current of 8 ampere. Okay. The field at the center O of the circular part. Okay, that's an easy question. So the field at the center O of the circular part. Okay. Um, so these straight segments, because they pass through O point, they will not produce any magnetic field at O. The only field will be because of the semicircular part, and the field because of that it is given by mu naught I by 2r into the fraction of the circle, this um, mu naught I by 2r. Yeah. We have to do the calculations here actually. So mu naught is what? Mu naught is 4 pi into 10 raised to power minus 7. Okay, then radius is given to us as 3 centimeters. So 3 into 10 raised to power minus 2. Okay, then I is given to us as 8 ampere, and eta is half. This is half of a circle. So this 2, this 2, this 2, and this 4 gets cancelled. So if I ignore the powers of 10 and I focus on numbers, so 8 is there, pi is there, 3 is there. So 8 pi by 3. And apart from that, the power that we will be left with will be 10 raised to power minus 5. So do we have an option like this? 8 pi by 3 into 10 raised to power minus 5 Tesla. Option A would be the right answer. So it's a simple application of the formula, guys. Wasn't a very difficult question. Just a bit of calculation was there. So the expectation was that you do the calculations correctly to get the answer to this. All right. Now comes question number 11, which is actually a which is actually a numerical question. So it says there are two concentric and coplanar coils C1 and C2. C1 has 500 turns and is in square shape with a side length of A, and is square in shape with a side length A. C2 has 1000 turns and a radius of 1 centimeter. All right. Okay. And radius. Okay. C1 carries a time dependent current this much, where T is in second. The EMF induced in C2 at time T equal to 2 seconds is this much. The value of A in meters is the value of A. The question says that the value of A is much more than 1 centimeter. So the situation is like this, that we have a large circular coil, and at the center of it a tiny we have a large square coil, and at the center of that a tiny square circular coil is kept. Okay, a tiny circular coil is kept. Okay, this one is C1, this one is C1, this one is C2. C1 has 500 turns, so let me write it as N1. C2 has 1000 turns, let me write it as N2. Okay, radius is given. C1 carries a time dependent current. Okay, So the time dependent current that C1 possesses, it will produce a varying magnetic field at the location of C2, causing the flux passing through C2 to change, and that change in flux will result in an EMF in C2. All right, and the value of that EMF is given to us at a certain time. So at least we understand the physics of the problem now. We have to start solving the question. Now to solve this question, the first thing that you need to be aware, or if you are not aware, then you have to figure out, is what is the electromagnetic field produced by this square loop at its center. So the question is, do we have a standard formula for that? Well, it depends on you. This is a question that we certainly do in the class when we study about magnetic field, but whether we remember it as a standard result or not, that may vary from student to student. So right now I'm not assuming that you have remembered this, you have memorized this. So I will find out. Okay, and to find out, what I can say that there are four current carrying wires of finite length, and all of them will produce magnetic field at center in the same direction. So we can find magnetic field due to one wire and multiply it with by 4 to get the magnetic field at the center. Let's do that. So, and to write magnetic field due to one wire, the formula that we are going to use would be mu naught I by 4 pi r, and then we use sine theta 1 plus sine theta 2. All right, so this angle is, let's say, theta 1, this angle is, let's say, theta 2, which in present case would be 45 and 45. All right, so let's do this. So it would be mu naught I by 4 pi. This r indicates the perpendicular distance, which should be equal to a by 2, and then sine 45 plus sine 45 will give us a root 2. So, and this is due to one wire. All right, this is due to one wire. Let me finish the calculation here. So we will end up with 2 root 2 by 4. That would be 1 upon root 2. So mu naught I by root 2 pi a. Now that's the contribution from one wire. Okay, if we are trying to write the contribution of the entire square, okay, so magnetic field at the center, the overall value would be mu naught I by root 2 pi a into 4. So that's one loop. But then we also have plural number of turns, n1. n1 is what? 500. Okay, so I will also multiply it with 500. All right, so what are we now getting? And the current was time varying, so I'm not substituting anything for the current right as yet. So this is what? 2000 by root 2 is 1000 root 2, 1000 into root 2. So we have taken care of these numbers. This number, this number, this number, they all end up giving us 1000 root 2. And apart from this, we have mu naught I by pi a. So this is the magnetic field at the center. Now flux passing through C2 would be magnetic field at the center into pi r square into n2. So this will become 1000 root 2 into mu naught I by pi a into pi r square. R was 1 centimeter. Yeah, that's correct. I remember it properly. So square of that will be 10 raised to minus 4. I'm keeping everything in SI units. And N2 was, I think, 1000. N2 was 1000. Okay. So what do we get from this? What do we get now? Okay. So 10 raised to power minus 4 into 1000, 10 raised to power minus 1 into 1000, 10 raised to power 2. Okay, so 100. When I take care of all this, I get 100. Okay, this pi gets cancelled with this pi. So we are left with 100 root 2. Okay, so I've taken care of this into mu naught into I by a. Okay, I've taken care of this. I've taken care of this. So nothing is left. So this is what we are getting as flux. Now, the question says that, see, current is this. The EMF induced at particular time, at this particular time is this. So I is this. Okay. So next we have to actually differentiate. Okay, like the EMF induced in magnitude, it would be given by d phi by dt. So the derivative of this is actually mu naught 100 root 2 by a. So it's mu naught 100 root 2 by a. Okay, mu naught 100 root 2 by a, and then derivative of I. So derivative of I would be 10t minus 2. Okay, so It would be 10t minus 2 and then mu naught into 100 into root 2 by a into time was 2 seconds, I think. Time was 2 seconds. Okay, so 10t minus 2, 20 minus 2, 18. All right, so this is the EMF that we are getting, and this EMF should be equal to this value. So 72 pi root 2 microvolt. 72 72 pi root 2 microvolt. So now we have to solve this to get the value of A. All right, let's do that. So this 18 gets cancelled, this becomes 4. Okay, and then 4 pi into 10 raised to the power minus 6. Let me make it as 10 raised to the power minus 7 and multiply with 10. That is doable. So this 4 pi 10 raised to power minus 7, this entire thing gets cancelled with mu naught. Okay, root 2 gets cancelled with root 2. So the value of A comes out to be 10. This 10 gets cancelled with this to leave a 10. So A comes out to be 10. And since we are doing everything in SI units, so A should be 10 meters. Okay, so A should be 10 meters. Let's check the answer, everyone. So 10 is given. That is the correct answer. All right. So question number 11. Lengthy question, I would say. Okay, good question. I'm expecting many of the students will probably commit mistake in this question, or even if they don't commit mistake, they'll probably give up halfway into the question. Okay, now question number 12. An infinitely long current carrying cylindrical straight wire. Infinitely long straight current carrying cylindrical straight wire has radius 2 meter. Okay, consider 2 points A and B, one inside the wire and the other outside the wire at a distance of R1, R2 from the axis. If both the A and B, the magnetic induction is equal, then find the product of R1 and R2. All right. So let me first draw the situation. So we have a wire, more like a cylinder, I would say. Okay, because the radius is pretty good, 2 meter. All right. So it has a radius of 2 meter. Okay, and it says the infinite long current carrying cylindrical straight wire has a radius. Consider 2 points A and B inside the wire and the other outside the wire. Okay, is equal to. Okay. So guys, there may be a doubt in your mind that whether whether we should have to consider this wire as a hollow thing, or see, if you consider it as hollow, then the magnetic field inside becomes 0 and the magnetic field outside will be non-zero. So the question will lose its significance. All right. So therefore, it shouldn't be that way. So therefore, the situation should be that current is flowing, like in this entire area, current is flowing in the upward direction. Okay. The current density may be J. Let's say that the current density is J. So if there is a point inside the sphere inside the cylinder at a distance r1, then the magnetic field at this point, all right, will be given by, it is mu naught J R1 by 2. That is the value, that is the formula, mu naught J R1 by 2. All right. And now if I talk about a point which is outside at a distance R2, all right, then the magnetic field at this point is written as mu naught into total current. The total current would be J capital R square. Okay, mu naught I by 2 pi R. Now these two are equal, so let's equate them. So if I equate them, I get mu naught J R1 by 2 is equals to mu naught J R square by 2 pi R2. Okay, so this is what I get. So mu naught gets cancelled, 2 gets cancelled, J gets cancelled. Okay, so R1 R2 product is how much? R1 R2 product. This is R square by pi. Am I right, guys? I think I've committed a mistake here. There should be a pi here also. No, I'm writing the area. I forgot to include that pi. So this pi will get cancelled. So this pi will not be here actually. So this pi will not be here. So R1 R2 will be equal to R square. So R is given as 2. So R square will become 4. So the answer will be 4. So 4 will be the correct answer. Is that okay, everyone? Okay. Now we'll go to question number 13. Let's see what this question has to say. So question number 13 says, two horizontal parallel long straight wires, two horizontal parallel long straight wire carrying current of 100 ampere each. Okay. They are in the same vertical plane and are separated by 1 centimeter. The upper wire is fixed while the lower wire is hanging in equilibrium under the effect of magnetic force and its own weight. Under the effect of its own weight. Okay. Yeah. So this is question number 13. Okay. the mass per unit length of the lower wire is. The mass per unit length of the lower wire. Okay. So guys, the situation is that this is the wire, this is fixed. Okay. This is fixed, and below this there is another wire which is actually hanging. And how is it hanging? So these two carry parallel currents of 100 ampere each. Okay, and because they are carrying 100 ampere current and they are parallel, so the upper wire will attract so the wires are attracting each other. Okay, so if I consider L length, any length L of this wire, then this is experiencing a force in the upward direction, and at the same time it will have a downward force because of its weight, which can be written as lambda Lg. So the two forces should balance each other. We have to equate these two forces. So let's do that. Okay, so F will be written as mu naught I by 2 pi r. That's the magnetic field due to the upper wire, into I, that's the current in the lower wire, into the length that we are considering, L. Okay. Now this is the upward force per on L length of the wire. The downward force would be lambda Lg. So what happens is we are trying to find lambda. Okay, so L gets cancelled, and then we have to just do the calculation. So mu naught by 2 pi is 2 into 10 raised to power minus 7. Okay, R is given to be 1 centimeter, I suppose. R was 1 centimeter, so that is 10 raised to power minus 2. 10 raised to power minus 2, and then I square will be 10 raised to power 4 because I was 100. Okay, so we have taken care of all these things, and G is there. So G would be 10. Let's consider G as 10. Was it given in the question? G was given to be 10, so there is no confusion there also. All right, so this is what we are looking for, and the unit in which we are seeking the answer is milligram per meter. Okay, milligram per meter. Okay, so what we are getting right now is kg per meter. So let's do this. So this becomes 10 raised to power minus 5. Okay, this becomes 10 raised to power minus 5, and then this becomes 3. So 2 into 10 raised to power minus 3. Am I right? 5 minus 3, 2. 2 actually, 2. Okay, so 2. Now we want to write milligram. So milligram per meter. So I think 20 would be the answer. 20 milligram per meter would be the right answer. Am I right? Yes, it looks like I'm right. Yes, 20 should be the answer, guys. All right, so 20 is the correct answer to this question. Okay, now we'll go to question number 14. Now let's see what this question says. A small loop of wire of area A and a small loop of wire of area A, n equal to 80 and resistance equals to 20, is initially kept in a uniform magnetic field B in such a way that the field is normal to the plane of the loop. When it is pulled out of the magnetic field, the total charge flows through the coil. The magnetic field B. So guys, I'll tell you what is the concept here. So there is, let's say there is a coil, and this coil is kept in a magnetic field. Okay, let's say this coil is kept in a magnetic field, and now magnetic field is changing due to whatever reason. Like one of the reason that is that we are pulling out the coil, or the magnetic field is, we are making the magnetic field to undergo change. Whatever is the case, there would be an EMF induced in this coil that would be given by minus d phi by dt, and because of this EMF there can be a current in the coil. That current will be given by E by R, or it will be given by minus d phi by dt into 1 by. We can ignore the negative sign, that doesn't really make any as far as the magnitudes are concerned, negative doesn't play any role. Now understand this. I is what? This is dq by dt, where dq is the charge that flows in the coil. So dq by dt is equals to minus delta phi by delta t into 1 upon r. This dt get cancelled. So what we get is that the flow of charge is equals to delta phi by r. So the flux change divided by the resistance gives you the amount of charge that flows in the coil. So this is what we have to do. Okay, how we have to do? Flux change. How much is the flux change? So initially there was a magnetic field, and eventually there was no magnetic field. So whatever flux was there initially, that is the equal to the change in flux. So we will calculate the initial flux, we'll divide it by resistance, and that should give us the answer. All right, so initial flux. So area is 0.01. Okay, so flux, how are we going to write it? We are going to write it BAN, number of turns. All right, we'll divide it by resistance. So that should us give this is the calculation we want to do. So B is how much? Or B we have to find out. Okay, charge is given, B we have to find out. So in that case, let's rearrange in a different manner then. We want to find out the value of B, right? So B will be given as QR by AN. Now Q was how much? 8 into 10 raised to power minus 2. So 8 into 10 raised to power minus 2. How much was the resistance? The resistance was 20 ohm. Okay, so into 20. Okay, area was 0.01, that's 10 raised to power minus 2 itself. And number of turns were 80. Number of turns were 80. Okay, so into 80. Now pay attention that this gets cancelled. This 8 and 0 goes. So we are left with 2 as the answer. So 2 Tesla would be the right answer. Alright, so 2 is the answer to this question. Now comes the final question of this test, question number 15. Let's have a look at this. Anyways, I think no worries. A current of 5 ampere is flowing in a linear conductor having a length of 80 centimeter. Okay, the conductor is placed in a magnetic field of strength 50 Gauss. Now, first of all, you should know what is Gauss, all right? But of course, you are writing the paper at home, so you can Google search it and you can immediately know if you don't know what is 50 Gauss. I'm expecting many of the students would have done, although that would amount to cheating, but I think some of you must have done that. Okay, the conductor is placed in a magnetic field of strength 50 Gauss. Okay, and make an angle of 30 degree with the direction of the field. It experiences a force of magnitude. The value of K is, okay, all right. Now, first of all, how much is 1 Gauss? I believe 1 Tesla is 10 raised to power 4 Gauss. I hope I'm correct here. Okay, so 1 Gauss would be 10 raised to power minus 4 Tesla. That should be the situation, and I think it should be correct. Okay, now the conductor is placed. So guys, how do we calculate the force? Okay, let me draw the situation. There is a conductor, it has got some length. All right, there is a current flowing in it. It is kept in a magnetic field of some strength moving in a 30 degree direction of the field. Okay, so this is the direction of the field, this is 30 degree. Okay, we want to know the magnitude of the force. So how do we write force? We write B sine theta into IL. That gives us the force. Now B is 50 into 10 raised to power minus 4. Okay, sine theta would be 0.5 because theta is 30 degree. L is 80 centimeters, so that's 0.8 meters. And that's it. Okay, so how much is this? So 0.8, 0.8 into 0.5 is 0.4. 0.4 is 4 upon 10. 20. So all these numbers, they become 20. Am I right? 0.4. Yeah, it becomes 20. So 20 into 10 raised to power minus 4 Newton is the force. If I compare it with the given thing, okay, if I compare it, so it's 0.2. The value of K should be 0.2 in that case. So let's check the answer, guys. It is coming out to be 1. Where did I commit a mistake? Guys, did I miss anything? Did I miss anything? I wrote B, 50 Gauss, B, sine theta. I did not. So guys, there would be a 5 also. I think I forgot to take into account I. Okay, I'm sorry for that. So an I 5 would be there. So 5 times of this. So it becomes 100 into 10 raised to power minus 4. So yeah, 1 into 10 raised to power minus 2. So 1 would be correct. Yes. So I would have scored a negative marks or 0 marks in this question if I had been writing the test. Alright students, I hope you enjoyed the paper. I hope whether you got selected in the Eklavya program or not, that's a secondary thing, but I hope that you really enjoyed writing these entrance tests. Alright, I hope many of you actually join the Eklavya program, and I'll see you in the program, and few months later, I'll see you on the other side of the IIT gate. Take care everyone. Bye-bye.
Hello everyone. So let us now discuss chemistry questions of your Eklavya test, right? So I hope you did really well in chemistry. So let us see what questions came and whether you get the right answers or not, right? So the very first question is E naught MnO4 negative slash Mn2 positive is x1 volt. The E naught for MnO2 and Mn2 positive is given as x2 volts, and you have to calculate the E naught for MnO4 negative to MnO2. So first you need to check the change in the oxidation state to calculate the number of electron transfer, right? So let me see what is the number of electron transferred here. So the oxidation state plus 7 to plus 2, that means In this N1 is 5 electron transfer, right? And here plus 4 oxidation state of manganese becoming plus 2. That means N2 here is plus 4 to plus 2, that is 2 electron transfer. Now here from plus 7 to plus 4, that means N3 here is 3, right? So you have 3 equations basically. In first, your MnO4 negative is becoming Mn2 positive. In second, your MnO2 is becoming Mn2 positive. And what you are supposed to calculate is this. So by looking at these 3 equations, you can clearly see what I can see. The equation 1, I can get equation 1 by adding second and third, right? I can add these two equations 2 and 3 to get equation number 1, and so is the relation between their delta G, gives free energy changes, right? You know, you cannot just add directly E naught values. So, but we can do with delta G naught. So, I can write delta G naught 1, this first reaction, is equal to delta G naught 2 plus delta G naught for the third reaction, gives free energy change. And I'm pretty sure that you all know delta G is minus NFE naught, right? So, for this N1, FE naught 1, here I have minus sign, N2, N, now the Faraday's constant, FE2 naught, and here also minus N3, FE3 naught, right? So, E1, E2 you know, E1, E2 values you already know, and N1, N2, N3 values you are aware of, right? Faraday's constant will get cancelled from both sides. You know N1, N2, N3 value. You know E1 naught value and E2 naught value, because these two values are given x1 and x2 volts. To put the values in the equation, and so that you can get the expression of E naught 3 in terms of x1 and x2. And I'm sure most of you who try to solve this question, they must have got the correct answer, guys. Yes, so indeed the correct answer of course is C. Very simple question. Just you are supposed to use the relation that gives free energy change, delta G naught is equal to minus NF E naught. That is pretty simple. Okay guys, let us move on to the next question. What is that? You have to calculate this ratio at equilibrium of the following cell. There is this cell given to you. You can see there is this cell. KSP of silver carbonate and KSP of AgBr is given to you, right? So KSP value is given to you, guys. You are expected to calculate this ratio, and that too at equilibrium, right? Equilibrium value you are supposed to calculate, guys. Yes. Now what we can do here is, so this is the question. Now there is this cell. You can see in this cell representation cathode and anode. Let me write cathode. What is the reaction happening in cathode? You can see here what reaction is happening in cathode. This is the cathode. Yes, reduction is taking place. Cathode reduction is taking place. So Ag positive from AgBr. This is from AgBr plus electron becomes Ag. And at anode, this is the cell representation. This part shows the anode where oxidation takes place, guys. So you can see Ag becoming Ag positive again, Ag becoming Ag positive, right? And of course, this is Ag2CO3. So you can write the overall reaction that Ag positive from AgBr gives Ag positive from Ag2CO3, right? And hence you can write the Nernst equation for this reaction, right? You can write the Nernst equation for this reaction, and of course in Nernst equation you will get the concentration of Ag positive from AgBr and the concentration of Ag positive, because Ag is solid, from Ag2CO3, right? So let me show you how you can do it. It is just very simple. You are supposed to write the Nernst equation. Here you can see this is the net reaction happening. and the Nernst equation, right? E naught is 0 and equilibrium. E cell, you have taken 0, E naught is 0 because both the compartments Ag positive ions are there. In one compartment they are getting reduced Ag and in another they are getting oxidized. So this is 0, this is 0. Simply putting the values in Nernst equation and the concentration. What is the use of KSP here? Because the concentration of Ag positive I can write as KSP of AgBr. This is the concentration of Ag positive from AgBr compartment upon the Br negative concentration, whereas the concentration of Ag positive in another compartment where I have Ag2CO3 upon the concentration of carbonate ions, right? Yes. So when you write the Nernst equation, replace Ag positive from Br by this expression, replace Ag positive concentration from Ag2CO3 by this expression, and of course because the reaction is at equilibrium, so this K becomes equal to 1. So you are just supposed to take this equal to 1 and you will get your answer, right? So at equilibrium that K value becomes 1. You are supposed to take that equal to 1 and you will get the answer on rearranging. So application of Nernst equation along with the basic formulas of solubility of salt, right? Let's move on to the next question, guys. What is the next question? Let's see quickly. A cell, there is a cell given to you. So I can see in anode, there is oxidation of Ag happening. In cathode, there is reduction of copper ions happening, right? So this cell contains 2 molar Ag positive ion and 2 molar Ag2 positive ions initially. The change in cell potential after passing 10 ampere of current for 4825 seconds. So first of all, initially, what is the E cell that we are supposed to write? E cell is equal to E naught cell minus 0.059 by 2, you can say. Yes. If the overall change we can take 2. So what is happening? Ag plus copper 2 positive ion. So it becomes Ag positive and copper. This is the reaction which is happening here. Yes, guys, this is the reaction that is happening here. So initial concentration is given to you, guys. You can write the expression log of Ag positive concentration upon log of copper 2 positive concentration, right? Initially both are given as 2 molar and 2 molar, that you can write. This is the initial. Now after passing 10 ampere of current for 4825 seconds, what will happen, right? So how much charge we have passed? How much charge? Q is equal to I into T. 10 ampere of current we passed for how much seconds? So that means how much charge did we pass? This much charge we pass, right? So you know the charge on 1 mole of electron is equal to Faraday's constant, 96500, right? So this much coulomb charge means how many moles of electron I can calculate? So moles of electron, or you can say the moles of Ag positive ions being formed, right? Because 1 mole of electron is required to oxidize, or you can say to oxidize 1 mole of Ag. So you can see Ag to Ag positive. So I can get that is equal to the charge upon Faraday's constant, right? Yes. So I'm sure you will get it as 1 by 2, 0.5 moles. So 0.5 moles of Ag, right? So this is the reaction and you are getting 0.5 moles of Ag. Got it, guys? Please see. So what is the change in the concentration now? After passing this current, the concentration was 2 molar. Now 0.5 more, so it becomes 2.5, the new concentration. And how about copper? So if 1 mole of Ag is oxidized, right? 1 mole of Ag is oxidized, that means half mole of copper is reduced, because Ag needs 1 electron to become Ag positive, whereas for the reduction of 1 copper 2 positive ion, we need 2 electrons, double the charge, right? So what is the change in the concentration of copper 2 positive ion? Copper 2 positive ion is becoming copper. That means initially the concentration was 2. Now it increased by 0.5 or it decreased by 0.25, the half of 0.5. So it will become 1.75. So the new concentration for Ag positive ion is 2.5, for copper 2 positive ion is 1.75. Again write the equation, the same equation, first equation, put the new concentration. You are supposed to calculate the potential difference, the initial E cell minus the new E cell, and I am pretty sure you will get the correct answer. What is the potential difference after passing the current, right? Yes. Or if you are doing it by like 1, so you can here take it 1 also. Like if you really don't want to balance the charges, if you are like doing the number of moles of charge transfer is equal to, the moles transfer of electron is equal to the charge moles of, electron pass. So you can take it 1 also. So you'll get your answer. Any which ways it will get cancelled. Yes, guys. So I hope you'll get your answer 2 times. You have to apply the Nernst equation, right? Nernst equation you are supposed to apply twice and see the difference. Okay, now the next question, question number 4. First, yes, the 4th question, guys. First order hydrolysis of ethyl acetate was carried out using 0.1 molar HCl and 0.1 molar H2SO4, in which case rate constant is higher. So rate constant is higher. Rate is directly proportional to the concentration of H positive and ester, of course. So I can say more is the concentration of H positive ions in the solution, right? More is the faster will be the rate, more is the rate of reaction. I can say that reflect in the value of rate constant. So we have HCl, same molarity, we have H2SO4, same molarity, but 1 mole of H2SO4 produces 2 moles of H positive ion. So when we use H2SO4, right, we have more H positive ions, more concentration of H positive ions in the solution. So hence the rate of reaction and hence the rate constant will be more. So indeed the answer is B, right? We have 0.1 HCl, 0.1 H2SO4, but because in H2SO4 we have more number of H positive ions, more concentration, hence the answer is this. Now the next question based on again kinetics, specific rotation. Yes. So I have this question. Consider the following reaction. A gives B. A is optically active and B is optically inactive. Calculate the angle of rotation after 5 hours with the help of the following data. Okay, angle of rotation you have to calculate. So again, use the equations for first order kinetics, guys. Use the equation for first order kinetics. Please read the question. Yes. Should I write the basic equation? I'm sure that you are pretty aware. K, rate constant 2.303 over T log of, yes, because which expression we are going to use, because we are given with the degrees, specific rotation data, right? So we have to use the equation which has this degree, specific rotation. So that is R naught at initial time, R infinity, this value upon RT minus R infinity, right? The same equation you are supposed to calculate for first this data. R naught is 0, R infinity, R naught is 0, R infinity is 2, RT is, what is RT here? RT is 60 minute as per the data. Sorry, T is 60 minute, RT is 77 degree. So as per this table, use this equation. You know all the values. T is 60 minute, R naught is 82, R infinity is 2, RT is 77 degree. Now again you have to write the same equation in which you know the time, that is 5 hours. That means 5 into 60 minutes. The new T becomes 5 into 60 minutes, guys. Yes. R naught, R infinity value remains same, 82 degree and 2 degree. In that case, you have to calculate RT. That is the angle of rotation after 5 hours. So, KT remains same, K and T remains same. Just equate the two equation, you will get RT. Yes, very specific if you know this form of equation. So, if you know this form of equation, I'm sure you can, do it nicely. Yes, guys, let me show you the, yes, please, here you can have a look. So, this equation, just use it twice and calculate RT. Done, guys? Yes, simple. I'm sure you must have solved it if you know this form of the equation for the first order kinetics. Next question, which of the following mixture can be separated by fractional distillation? If there is not much difference in the boiling point, that can be separated by fractional distillation, a conceptual question. So, as you look at the option, you can see there is a benzene and toluene. Bhai, right? So, benzene and toluene, not much difference in their boiling point. So, we have to separate them not by the simple distillation but by fractional distillation. And if you did it right, well done, very nice. Yes, let's move on to the next question, guys. Solubility of gas in H2O depends upon. So, Henry's law, the solubility of gas in liquid, it depends upon, I'm sure you know the Henry constant and the pressure. So, it depends upon the temperature, the pressure, and also, of course, the nature of the gas. Right? So, KH value depends upon, because you know the Henry law, there is Henry constant, temperature dependent, gas dependent. So, we have temperature, pressure, and nature of gas. The answer is all of above. Right? So, whenever there is a question in which there is an option all of above, just make sure that you check all the options, right? So, indeed, the answer is D, donkey. That is all of above. Okay, let's move on to the next question. The question number 8. Now, N2O5 decomposes to give NO2 and O2. So, first you are supposed to write the reaction, right? Just write the reaction. What will be the reaction? Write the reaction. Then you can solve. N2, let me write. N2O5 decomposes to give NO2 plus half O2, right? This is the reaction. Following first order kinetics, that means we are supposed to use the equation for the first order kinetics if required. After 50 minutes, the pressure inside the vessel increases from 50 to 87.5 mm of Hg. So, initial pressure was 50 mm, right? 0. After 50, how many minutes? After 50 minutes. After 50 minutes, so this decomposition happens, P1, this is 2 P1 and this is half of P1. So, after 50 minutes, the pressure becomes 87.5 mm of Hg because of the decomposition of N2O5, right? So, I can say after 50 minutes, the total pressure inside the vessel is the sum of all the pressure of all the gases, that is equal to 87.5. From here, you can calculate the value of P1. Yes, so by solving this equation, I can get the value of P1. So it is 50 plus 3 by 2 P1, 37.5. Oh, 87.5. Yes. So from here you can calculate your P1 is 37.5 into 2 by 3. That's 75. That is your P1 pressure comes out to be, let me write here only, P1 is 25. So put the value of P1 here. That means after 50 minutes, how much pressure is left for your N2O5? That is 25. Initial was 50. After 50 minutes, it becomes 25. That means half. half-life of N2O5, first order kinetics. Yes, initially 50 pressure, after 50 minutes it becomes half of its initial value, that is 25. The pressure is half, right? That means 50 minutes is the half-life of this. Now, the question is the pressure of gaseous mixture after 100 minutes. Now we know the half-life. So after next 50 minutes, it will get halved. So now what is the half of 25? 12.5. So after, 100 minutes in total, the pressure of N2O5 becomes 12.5. Initially it was 50. In 50 minutes it becomes 25. In next 50 minutes, that is total 100 minutes, it becomes 12.5. Now I am sure the question is pretty simple. Once you know after 100 minutes what is the pressure of this, you can calculate 1 mole of this, give 2 mole of this and half mole of this. If this is 12.5 is the remaining, right? How much it reacted, and you can calculate what will be the pressure of NO2 and O2 after 100 minutes. Just total that is required. They ask you what is the total pressure, right? So indeed the answer will come out to be this. So let me show you this way you can go about it. Yes. So you can check if you didn't get it correct, where you did the mistake. It was not a tough. So it is pretty simple. You can solve, right? So the total pressure after 100 minutes. Total pressure means after 100 minutes, N2O5, NO2 and O2 the total pressure they ask you. Okay, got it guys? Okay, let's move on to the next question. Now, the next question is which of the following statement is correct? Which is correct? Now, let's see. pH 3 reduces AgNO3 to Ag, perfect. So, when pH 3 phosphine reacts with AgNO3, Ag is formed indeed along with H3PO4, HNO3. So, indeed the first statement is correct. So, this is a correct statement. Organic tissues turn AgNO3 black by reducing it to Ag. Yes, of course, this is also true. AgCN is soluble in KCN. Yes, because there is a complex formation. This is the complex that is formed. So, this is also true. So, all the correct statements are there in this. So, I'm sure if you know these basic reactions of inorganic chemistry, you got it right. So, the answer is D, donkey. All are correct. Okay. Let's see the next question, guys. The next question is from coordination compound, the isomerism part of coordination compound, which is indeed very important from the chapter, right? So I have octahedral complexes can exhibit both optical and geometrical isomerism, whereas tetrahedral complexes do not exhibit geometrical isomerism. Scale planar complexes exhibit optical activity when their ligands have chiral carbon, right? So M is central metal, A, B, C are monodentate ligands, A is symmetrical bidentate ligand, AB is unsymmetrical bidentate ligand. Which of the following complexes may result into optically active complex on substitution of A by B? You are supposed to substitute ligand A by ligand B. So let me quickly write that first by substituting A by B. If I substitute A by B, so I have this complex become A2, B4. When I have this, it becomes A4, B2. Now this, it becomes MA3B3. Facial and meridional type of isomers you will get here, right? And the last one becomes MA2B2C2. Now you are supposed to tell which now have optically active complex, like isomer which are optically active. I will recommend all of you to definitely read a table given in the JEE Sudarshan Guha, like Indian edition for inorganic chemistry. I'm sure most of you are following. In that particular book in coordination, there is a beautiful table there, right, in which they summarizes the various probability, all these types of complexes, the various type of complexes, and how many geometrical isomers are there, how many optical isomers or enantiomers are there, how many total stereoisomers are there. So I highly recommend each one of you to definitely read that table from JEE, right? Yes. So it is very much direct if you know that table now, because Otherwise, you have to check the plane of symmetry, cis, trans, isomer, everything. It will take a lot of time every time, right, to check each and every complex. So if you remember that table, it will be really quick for you to do this type of questions. So in all these, you can see there we have cis trans, there we have cis trans, optically inactive isomers, right? Facial and meridional, again optically inactive. In the last one, 2 monodentate A, 2 monodentate B, and 2 monodentate C. So that means the optically active isomer I will only get in this C option, right? Yes. So indeed, D option. The answer is D. So cis trans optically inactive again in the next, because both are same, like A to B4, A for B2, similar kind, because AB both are monodentate ligands, right? And here I just told you facial and meridional. And here we have a complex where you can get optically active isomers. So in that table, you can see they have geometrical isomer, geometrical isomer, geometrical isomer. In that table, you can see that the number of enantiomers 0, 0, 0, right? Hey, you can check and let me know in the comment section of the video how many total stereoisomer for this. Indeed, there is optically active enantiomers are there. So let me know how many total stereoisomers for Ma2B2C2 complex. Okay. So let's see, interesting question. This is pretty interesting question, I'll say. Okay. How many of the following are concentration cells? So how many are concentration cells? You are given 4 options, the cell representation, and you are supposed to tell how many of them are concentration cells, right? I hope you know. There are 2 types of concentration cell. One is electrode concentration and another is electrolyte concentration cell, right? And E0 is 0 for concentration cell, because same reaction happening in cathode as well as anode compartment. So E0 of the cell is 0. So you have to look which is concentration cell. You might get confused by the various cell representation, as it seems they all are same, but please be careful. The first, you can say metal electrode, metal ion electrode. The first one is metal ion electrode. The second, metal ion electrode, but metal insoluble salt electrode. And metal electrode and metal insoluble salt, these 2 electrodes have different E0 values, right? Third one, again metal insoluble salt with AgCl, or you can say Cl negative ions. Here I have metal insoluble salt with Br negative ions. Again E0 will be different. Now here I have metal ion electrode, metal insoluble salt electrode. So as I told you that for concentration cell, E0 has to be 0. So only in one, where in anode and cathode, both the compartments, we have metal ion and metal electrodes, the E0 will come out to be 0. The answer is very tricky question, you can say. The answer is 1. Only 1, and that is the first option, right? Yes, because metal ion electrode potential is different than from metal insoluble salt electrode potential difference, right? Okay, let's move on to the next beautiful question of the paper. In aqueous solution of 1 into 10 to the minus 3 molal, there is a complex given to you, and there is an aqueous solution. Molality is given to you. Depression in freezing point is also given to you. Determining the sum of primary and secondary valency of the complex. A beautiful question in which the coordination compound concepts and also solution and colligative property, the basic colligative property equations are being used here, right? So let us see what we can do here. So delta TF is equal to I KF into M. You know this, you know this, you know this. So I'm sure you can calculate I, that how many ions this complex will give on dissociation, right? How many ions it can give on dissociation. You can calculate from the data given, everything is given to you. So I will come out to be 4, that means 4 ions this complex will give. That means this X has to be 3. Then on dissociation, I will get on dissociation 3 K positive ion and 1 this iron. Now I hope you can calculate the oxidation state of iron here. Yes, because for primary and secondary valency, you need the oxidation state on CMA and the coordination number, that is 6. How many ligands are bonded to CMA. So I can get the oxidation state of iron here is +3. So primary valency, secondary valency, 3 plus 6, coordination number, oxidation number, both we get, and we can answer it easily. So answer indeed is 9. They asked us the sum of secondary and primary valency of this complex. We are just supposed to know what is X in the formula, right? Okay, it won't take much time. Now let's move on to the next question. Okay, I can see so many complexes in this. So if the number of complexes in which stability constant value is greater than the stability constant value of this, so more stable is the complex, more is the stability constant, stronger is the ligand, right? So better is the stability of the complex. So you have to see how many complexes are more stable than F6 negative. F negative is a weak field ligand. Let's see how many are stronger or like stable complexes as compared to this. So we have cyanide, we have oxalate, ammonia, water and ethylene diamine. CMA is same, the ligands are different, and all these ligands, Ca negative, right, OX2 negative, ammonia, water, ethylene diamine, they all are stronger ligands as compared to your fluoride as per spectrochemical series. So 1, 2, 3, 4, 5, all the 5 are more stable as compared to the given complex. Okay. And if the number of complexes which have at least one 5-membered chelate ring formed by 2 carbons, 2 nitrogen and 1 CMA is Y. So in all these complexes, you have to figure out those complexes in which there is a chelate ring with 2 carbon, 2 nitrogen, right? Okay, EDT, of course, ethylene diamine tetraacetate ion. Now ethylene diamine also CH2, 2NH2. Glycinato, no, there is only 1 nitrogen here. Bipyridine, indeed 2 rings, 6-membered carbon rings having nitrogen. So of course this is also, you should know the structures of these ligands, right? Then only you can answer. And then oxalato, of course oxalato doesn't have any nitrogen. Okay, diethylene, okay, diethylene triamine. So again we have nitrogens, we have carbon which can form a chelate ring. So you are supposed to figure out those complexes which are having 2 carbon, which are having 2 nitrogen along with CMA in the ring. So EDTA, ethylene diamine, bipyridine and diene. These are the complexes. That means 4 complexes out of those satisfying the given condition. So X was 5 and Y was 4. So 5 by 4 should be your answer. Yes. Right. So the answer indeed is 5 by 4. Got it, guys? Next question. Let's come to the next question. This question is like time consuming question. Right? I don't know how many of you have solved this correctly. This is a time consuming question. Some questions are meant to be, those questions in the paper which takes a lot of time than expected, right? So let's see this question. What is it? A solid cube of edge length, the edge length is given to you, of an ionic compound which has NaCl type structure. So you should also have the idea what is NaCl, rock salt type structure, right? Type lattice. So guys, that is added to 1 kg of water. The boiling point of this solution is found to be this, okay? Assume 100% dissociation ionization of that ionic compound. If the radius of anion of ionic solid is 200 picometer, then calculate radius of cation of the solid in picometer. Okay. So first what I can get from this question is, there is an ionic compound, there is a solid cube of ionic compound. That ionic compound has NaCl type, rock salt type structure, right? So delta TB, the elevation in boiling point is given when that cube is being dissolved in 1 kg of water. So delta TB is equal to I kb into m. Yes. So guys, delta TB is given to me 0.25 and I know the kb of water. Molality of that is come out to be, molality will come out to be 1. That is the molality. 1 mole of particles are present in 1 kg of solution. 1 mole of particles, colligative property, right? So what is actually the moles of ionic solid in 1 kg water? Solid in cube. Because it dissociate, 100% dissociation. That means if we have 0.5 mole of that ionic solid, that will dissociate to give 1 mole of particles. That means in that solid cube, how much ionic solid is there? How many moles of ionic solid is there? 0.5 moles of ionic solid is there, right? Yes. So 0.5 moles of ionic solid in that cube. Now the number of compound or the number of molecules, or you can say the formula units, the number of molecules you can say in half mole will be 1/2 into Avogadro's number. Moles I know half. 6.023, it can be more precise. These many moles, these many molecules of that ionic compound, or you can say not molecules, the formula unit is a better term to use for ionic solid. So these many formula units are there in one solid cube, right? Yes. Now how many unit cell in that one solid cube? It has NaCl type structure, and if you know rock salt type structure, in one unit cell we have 4 sodium ions, 4 chloride ions. That means 4 NaCl formula units make one unit cell. So the number of unit cells of that ionic compound in that one solid cube is 1/4, because 4 formula units will make one unit cell. Now you got the number of unit cells. Yes, number of unit cells of ionic solid in that one solid cube. What else is given to us? The edge length of that solid cube, right? These are the number of unit cells. I got the number of unit cells. Yes, I am supposed to calculate the edge length of one unit cell. I have to calculate the edge length of one unit cell, right? So how can I calculate the edge length of one unit cell? Because once I get the edge length of one unit cell, I can easily solve. Yes, so number of unit cells I have in that cube, I know what is the length of that cube, right? This is the length of that cube. And number of unit cells, how many unit cells are there, that also I have. So what I'm supposed to tell, what next I need to figure out is the edge length of one unit cell. Yes, how you can do it, you can think about it. As I told you, this question will take a lot of time. I'm sure this must have taken a lot of time, those who try to solve it, and I don't know how many of you got it right, but I just wish if you are spending so much of time, then you must got it right. Finally, we have number of unit cells. Number of unit cell you got, and this is the number of unit cell. So number of unit cells, how many unit cells are there along the edge of this cube? Edge of cube. This is the total number of unit cells in that solid cube. So that will be the cube root of this value, of course. This is the number of unit cells along the edge, right? So you got the number. You know the edge length divided by this number of unit cell along the edge, you will get the edge length of one unit cell. So ultimately, I'm supposed to calculate the edge length of one unit cell. And for NaCl type structure, I know edge length of the unit cell, this is the unit cell, that is equal to 2Ra plus 2Rb, radius of cation and anion. And already radius of an ion is given. I got to know the value of A. I can calculate the radius of cation. So a bit lengthy question, time consuming question, right? But I'm sure if you solve it, you will enjoy the question. Solid state with solution and colligative property, right? You can see here, guys. As you can see, number of unit cell you got, number of unit cell along the cube that you got along the edge of the cube. This are the number of units along the edge of the cube, and this is the total edge length. So you can get the length of edge of one unit cell, that is this. So that is the total length of a unit cell. And for NaCl type structure, what is the relation between edge length with Ra and R negative is? That is twice of Ra plus R negative, right? R positive plus R negative, cation plus anion, right? So what is expected to know in this question? 1. The basic formula of elevation in boiling point. 2. The NaCl type structure. What is the relation between edge length and what is the relation between like edge length and R positive and R negative, and how many formula units are there per unit cell in NaCl? If you know these things and if you have the basic mental aptitude, you can definitely solve this question with the given data easily, but definitely time consuming one. Let's move on to the last question. Let's see what is that question. Okay, we have 4.48 gram of monobasic acid that is dissolved in 100 gram of benzene. Boiling point is increased by this. Delta TB is there. Calculate the molecular weight of acid in the benzene. No change in the molecular formula. So I'm sure this is a pretty direct question. You know the basic equation. Delta TB is equal to IKBM. This is the molality, moles of solute, right? Given mass by molecular mass divided by mass of solvent, that is also given to you, right? Moles of solute, given mass divided by molar mass. Simply by using this equation, everything else you know, you can calculate this question, right? Just calculation time it will take, nothing else. You can see just calculation time it will take, and I'm sure like most of you did it right. 728 is the final answer. That is the molecular weight of that acid, right? So with this, we are done with the chemistry portion of the test. I'm sure you enjoyed this paper, and there are few questions which are time consuming. There are 1-2 questions which are a bit tricky to solve. Rest every paper, like every other question in the paper is checking your fundamentals or basic, right? So I'm sure you are scoring really good. I wish you are scoring really good in your chemistry paper. So all the best everyone.
Hello, welcome everyone. I'm Surendra Jain, Master Teacher of Maths in Vedantu. I'm discussing Eklavya Entry Test 2 that was conducted this Sunday. And this is the first question which says A is a 3 into 3 matrix with elements like A, B, C at some positions and rest of them are 0. And ABC product is equal to 8. We have to find the higher powers of A in terms of A or I. So to do such question, what we need to do, we will first try to find out the A square. And if we find A square and then A cube, maybe we will observe some pattern. Okay, so here if I find A square, first row multiplied with first column will give you 0. Likewise here also it gives you 0. First row last column gives you AB. Here second row first column gives you BC, then 0 0, and here I think 0 AC and 0. You can check the calculation. Okay, for this element last row first column, so yeah, AC will be there. Now that is the A square, but if I find A cube, you will see what we get. We are getting ABC here, 0 0 here, 0 ABC here, 0 0 0 ABC here. Okay, now because ABC is 8, so if you put it here 8, I think it becomes nothing but 8I. I can write this as 2 cube into I. Now if I try to find the higher value, higher power of A, like if I want to know what is A power 4, I think we just need to multiply A with 2 cube I. So it will be 2 cube A. If I do A raised to the power 5, it will be 2 raised to the power 3 only, but A square here, because for this A power 5 I need to multiply A square here, so it will be 2 power 3 into A square. But if I do A raised to the power 6, okay, it will be actually the square of this, so we will be getting 2 raised to the power 6, 2 raised to the power 6 into I. So you can check for every power that is multiple of 3, we will be getting 2 raised to the power 3n into I. And other than that, like if you're writing A raised to the power 3n plus 1, it will be 2 raised to the power 3n only into A. Likewise, A raised to the power 3n plus 2, you will be getting 2 raised to the power 3n into A square. Now you can check the options. 2024 is not a multiple of 3, it's at this type of number, 3n plus 1. So I think that A option is not correct, because the power here would have been 2022. I think this is a number of category 3n plus 2. So the a raised to the power 2004 would have been this thing 2 raised to the power 2022 into a square. So a is wrong. I think only correct option is B here. So this is how you can do this question. Let's move to the next question. We are given n denote the sets of natural number and R is a relation on n into n. Please remember, my relation is not on the set n, it is on n into n. And what does that mean? Please understand, it means a set where ordered pair will be written like this, 1 1 1 2 and so on. Okay, so relation on these on this set where one ordered pair will be related to another ordered pair, and the condition is like that first element should be equal to the last element, second element of the other ordered pair, and likewise this B should be equal to C. Then A comma B is related to C comma D. Okay, now we have to check whether it's a reflexive, symmetric or transitive. Now first let's check for reflexivity. For reflexivity, we need to check whether every ordered pair like A comma B is related to A comma B or not. Now from this condition, it should be that this A should be equal to this B and this B should be equal to A. But that may not be true in general if A and B are different. And in this n into n, we will be having all type of ordered pairs. So this kind of ordered pairs 1 comma 2, 1 comma 3, they will not be related to themselves. So this is not true if A is not equal to B. So not reflexive. So it is not reflexive. Okay, for reflexivity, I think it is done. Now coming to symmetry. Now if we are looking for symmetry, how do we do? We first assume that some A comma B is related to C comma D. But if that is so, then this A will be equal to D, A will be equal to D and B will be equal to C. Okay, now for symmetry, we have to check whether C comma D, order changed, C comma D is related to A comma B or not. Now this to happen, we will require from this given condition C equal to B, which is actually true, and D equal to A, which is also actually true. So we can say that if A comma B is related to C comma D, then C comma D will also be related to A comma D. So this relation is symmetric. Now if we are looking for transitive, I think we will require 3 ordered pairs. Okay, we will require 3 ordered pairs. Let me write it here. Suppose we are having A comma B related to C comma D and C comma D related to E comma F. In that case, from the given condition, my value of A will be equal to D and this D will be equal to E. And this B will be equal to C and this C will be equal to F. Okay, but in order this relation to be transitive, I will require that A, B is related to E comma F. For that, we will require A to be equal to F. But here you can check A may not be equal to F in general. Okay, for specific values it can be there, but there can be many ordered pair where A and F are different. And likewise, we will require B to be equal to E, but B may not be equal to E, hence not transitive. Hence it is not transitive. So among the options, if I go, answer should be symmetric only because it is not reflexive, it is not transitive. So answer will be C for this question. Okay, now moving to the question number 3. Yeah, this was C option. Now moving to the question number 3, where we are given f r to r be a function given by this fx is equal to minus f of minus x, which means function is odd. And there is one more condition, f of 1 minus x is equal to f of 1 plus x. Now to do such question, what we can do, we can take this 1 minus x as y. If I take 1 minus x as y, then x will be equal to 1 minus y. So my first relation will become f of y equal to f of, I think, 2 minus y. In place of x, if you put 1 minus y, so 2 minus y. Also, if I replace y with minus y, the same relation will be equal to f of 2 plus y. Okay, now I will combine these two relations where f of y is equal to negative of this, negative of f of minus y means it will be negative of f of 2 plus y. Okay, now what this result says, please understand that whenever y is increased by 2, the input for function is increased by 2, from y it becomes 2 plus y, then the value of function changes its sign. Okay, now if I use this relation once again and I write f of 2 plus y, I can write it directly. It will be minus of f 4 plus y, because for every time you change this input by 2, increase or decrease by 2, there is a minus sign here. And if I combine these two together, I think we will be getting fy is equal to f of 4 plus y. So what you can see that whenever there is a difference of 4, they are same. Whenever there is a difference of 2, there is a minus sign. In fact, this can be generalized like this also, that f of y is equal to f of 4 plus y can also be written as f of 8 plus y, and so on. So we can say whenever there is a difference that is multiple of 4, they will be equal. So you can see 2024 and 2004, they have difference of 20, that's a multiple of 4, so they are equal. That means this whatever is written is correct, but we are looking for incorrect here. So if we are looking for incorrect, this is not the answer. Likewise, 2006 and 2014, there is a difference of 18. Now remember, if I write 2006, so if I add 4 to 2006, it will become 2010, and they will be equal, because for difference of 4 they are equal. So f of 2006 will be equal to f of 2010, f of 2014, and so on. I think f of 2022 will also be equal to f of 2006. Okay, and here then there will be difference, remaining difference will be of 2. So from this relation we can say it will be minus of f of 2004. So here B option is also, the information written is correct, so answer is wrong. Likewise, if you keep doing, I think C option is incorrect, the information written here is incorrect, so C will be the answer, because the difference here is 6, and for difference of 6 there should be a minus sign in between, so this C is correct. And D option also you can check that information given here is correct, because difference is of just 4, so they will be equal, so correct answer of this question should be C. Okay, now moving to the next question, that is fourth. We are given determinant of A is not equal to 0, and we are given a relation a minus 2i into a minus 3i is equal to I. Then we have to find the inverse of this. Okay, now to do this question we will multiply them, so we will be getting a square minus 5a plus 6i is equal to I. Now because we are looking for inverse of a minus I will try to write this expression in terms of a minus I. So 1a minus I can write a minus 4i here, so that my first two terms are achieved by this multiplication, a square and minus 5a. But because of this I terms will change, and to balance the terms of I, you have to write minus I on the right hand side. You can check, earlier it was 5i, now also it is 5i on the left hand side. So if this is minus I can write a minus I into negative of a minus 4i equal to I. So from the definition of inverse of function, I think this quantity or this matrix has to be inverse of a minus I. So answer for this will be 4i minus a, that is D. Okay, you can check the calculation. And then moving to the next question, that is question number 5. We are given trigonometric equation where x is variable and a is arbitrary constant has a solution if. Okay, now please see here, we know that for sine inverse function the principal range is from minus pi by 2 to pi by 2. So the solution will be only if this entire thing lies in minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. Okay, and for that this sine inverse 2a upon 1 plus a square should be less than pi by 4 and greater than minus pi by 4. I can write it as combinedly with mod sign here, that sine inverse 2a upon 1 plus a square should have mod to be less than pi by 4. Okay, that means my 2a upon 1 plus a square mod should be less than or equal to 1 by root 2. Okay, now we can simplify this with the help of wavy curve, or I think I can multiply 1 plus a square that side, so it will be, or root 2 will come here because all quantities are positive, so it will become 2 root 2 mod A to be less than or equal to 1 plus a square. 1 plus a square is always positive, so we can write like this. Okay, so here we will be getting a square minus 2 root 2 mod A plus 1 to be greater than or equal to 0. So a square is also mod a square, so it's a quadratic in mod a, you can say, and the root in this for mod a will be, if I put this equal to 0, I think it will be root 2 plus or minus 1, you can check. Minus b will be 2 root 2, then plus minus under root of 8 minus 4 is 4, so root after root it will be 2 and divided by 2, so it becomes root 2 plus minus 1. Now because this is greater than or equal to 0, so my mod a should be equal to either greater than or equal to root 2 plus 1, or mod a should be less than or equal to root 2 minus 1. So that will be the solution. Now we can check from the options like a equal to 3. I think a equal to 3 satisfy the first condition, so that will give you a solution. Now all real values are not possible, obviously, because between root 2 plus 1 and root 2 minus 1 there will be some numbers, and if my mod a becomes equal to them, then we will not have solution. Mod a less than half, here mod a is less than root 2 minus 1, which is approximately equal to 0.404. So if it is less than half, you can see between 0.04 to 1 by 2, if your mod a takes value, then you will not have solution. So for C condition also, for all values of a such that mod a is less than half, we will not get solutions. Similarly, a equal to minus 2 doesn't satisfy any of the condition, because for a equal to minus 2, mod a will be 2, whereas we want mod a to be greater than 2 point something, because it is 2.404. Yeah, so this is also not satisfying any of the condition. So answer for this question is A. Bit tricky question. Here the solution is given bit differently. You can go through that also. Moving to the next question, question number 6. Here we are given fx as function given in two parts. It is differentiable at x is equal to 1. Then we have to find whether it's continuous, differential, and so on. So first of all, maybe we can break this function into parts. Like if I start writing it as fx equal to, for less than minus 1, I think the first condition will be applicable. Not first, sorry, last condition will be applicable. So x plus 2 upon mod of x plus half. This will be for x less than or equal to minus 1. Okay. See, when mod x is greater than 1, greater than or equal to 1, then x can be either greater than 1 or it can be less than minus 1. My fourth condition will also be coming from this only. X by 2 upon mod of x plus half. This will be x greater than or equal to 1. In between condition, when x is within 1 and minus 1, this condition is given by ax square minus b. Okay, now we are looking for continuity or differentiability at minus 1, given that it is differentiable at 1. Now if it is differentiable at 1, it should be continuous there. So for continuity at 1, we will be using these two relations. Here it will be a minus b at x is equal to 1, left hand limit, and right hand limit will be, if you put x is equal to 1, it will be 3 upon 3 by 2. That gives you 2 only. Okay, so that is the one equation. One more thing, when x is greater than 1, this x plus 2 upon mod x plus 1, x plus half is same as removing mod. And also one more thing I will do here, I will write x plus 2 as x plus half plus 3 by 2, and in the denominator it will be x plus half. Okay, so for this part what you can see, we can write it as yeah, let me write it here. We can write it as 1 plus 3 by 2 whole divided by x plus half. Why I am writing like this? Because it will make the differentiation easy. Now if we need to make sure that it is differentiable at x is equal to 1, your left hand derivative will come from here, which is 2a, and right hand derivative will come by the differentiation of this, and it will be minus 3 by 2 upon x plus half whole square, and then putting x is equal to 1. So we will get 1 plus half whole square here. So that is also 3 by 2. So after simplification it will become minus 2 by 3. So this gives you A is equal to minus 1 by 3, and if I put A here, we will be getting B equal to A minus 2, that means B equal to minus 7 by 3. So these are the values of A and B we are getting for this function to be differentiable at x is equal to 1. So C option, D options are not matching, so either it will be continuous at x is equal to minus 1, or it will be both continuous and differentiable. Let us see what can be the correct answer. Now I think for minus 1 we can do it directly here. Minus 1, the limit is coming out to be, let me use space here, at x is equal to minus 1 we have to check the differentiability. So f of minus 1 minus, that is the left limit. If I put it here, it will be given by 1 in the numerator, and minus 1 plus half, that will be minus half, but with mod it will be half, so it will be 2 here. Now f of minus 1 plus, that's the right hand limit at x is equal to minus 1 will be given by this, and here it will be equal to A minus B once again. And you can check the value of A was minus 1 by 3. In fact, A minus B was one equation. From there also you can get it is coming out to be 2 only. So function seems to be continuous. Function is continuous at x is equal to minus 1. But if we do the differentiation, let us do it here, f dash minus 1 minus. To do the differentiation, I think I will need the differentiation of this, and for f dash minus 1 plus, I need to do the differentiation of this, which will be minus 2a, because 2ax, putting x is equal to minus 1, it will be minus 2a, and a is this, so I think it is 2 by 3. Okay, 2ax, putting x is equal to minus 1, so minus 2a, and putting a is minus 1 by 3, so it is 2 by 3. Now to get this thing, let me use space here because I am not having it. So for x is equal to less than minus 1, for x less than minus 1, my expression is x plus 2 upon x plus half. Okay, so I will be using here for x less than or equal to minus 1, the expression was x plus 2, and because this will be negative if you put x less than minus 1, so I will be writing it as minus x plus half. And I'll do the similar trick which I did here, so I will write it as x plus half plus 3 by 2 upon minus of x plus half minus. Okay, so it will become minus 1 minus 3 by 2 whole divided by x plus half. Okay, now if we do the differentiation, so this f dash minus 1 minus from this relation will be just do the differentiation, minus sign will go 3 by 2 and divided by whole square of this thing, where x will be minus 1, so minus 1 plus half whole square. So if we do the further calculation, it becomes equal to this will be 1 by 2, so it will go 4 there, I think it becomes 6 here, 3 into 2, 6 here. So this derivative is coming out to be 6, whereas my right hand derivative was coming out to be 2 by 3. So you can see these are not matching, so function is continuous but not differentiable. Okay, let us see what are the values given here. Yeah, a is coming out to be minus 1 by 3 and b is coming out to be minus 7 by 3. The rest of the things are not done here, but I have told you. Okay, now moving to the next question, that is question number 7. Very interesting question, bacho. Here we are given s as a function given by fx equal to ln x whole cube plus 3 ln x whole square. A comma fa, b comma fb, and c comma fc, where a less than b less than c are points of tangency of 3 tangents drawn from origin to the curve s. Then we have to find the product abc. Now please see how this question can be done. Here this can be some curve, maybe, sorry, yeah, this curve can be somewhere like this. I don't know what kind of curve will it be. Now from origin we are drawing tangents. From origin we are drawing tangents. It can be here, it can be here, and it can be somewhere else also. Now suppose this is the point. I am not taking a comma fa, rather I am taking t comma f of t, where t can be a, b and c. Okay, now please listen carefully. From origin 0 comma 0, if I drawing a tangent, slope of that can be equal to f of t upon t, using point slope 2-point formula, y2 minus y1 upon x2 minus x1, and that will be equal to f dash t also, because at any given point the slope of tangent is given by derivative of that function at that point. So ft is actually this thing, so it will be ln x whole cube, not x, it is actually in terms of t, yeah, it is in terms of t, so f ln t whole cube plus 3 times ln x whole square divided by, again I have written x, let me write it t upon t here, and on the right hand side f dash t means it will be 3 ln t whole square upon t plus, and this will be 3 into 2 6 ln t upon t. Now in this you can see this 3 times ln t square upon t will cancel this, so we are left with only 2 terms in which t will also cancel. Okay, so we are left with ln t whole cube is equal to 6 times ln t. We can do the factorization and we will realize that ln t will be equal to either 0 or it will be equal to 6. In fact, root 6 minus root 6, you can check. Ln t will be equal to 0, root 6 or minus root 6. So here the values of a, b, c can be found because the values of t are 1, e raised to the power root 6, e raised to the power minus root 6. So one of these can be taken as a, other two can be taken as b and c. Now we are looking for product abc, so if you multiply all of them your answer will be 1, that is given in D. Okay, so that completes this question. Now moving to the next. Here we are given from a fixed point A on the circumference of a circle of radius A, let perpendicular AY fall on tangent at a variable point P on the circle, then we have to find the angle PAY for which this triangle APY has greatest area. Please see what they are saying here. We are given a circle. Okay, on the circle I can take a fixed point here, and without loss of generality this fixed point A can be taken at a comma 0 also, where circle is such that its center is at origin and radius is A. Okay, so here you can see I am taking a point like this, and P is some variable point, maybe here, where you are drawing a tangent. This is my P point, and from A we are dropping a perpendicular, let's say M. Yeah, M they have given. A, Y they have given, not M, they have given Y. Okay, and they are talking about the area of triangle APY. Suppose the center is somewhere here, origin. Okay, now listen carefully. I'll take this angle as theta. I'm taking angle PAY because that is what we are looking for. So if I take PAY as theta, and that's the perpendicular, so this will be 90 minus theta. And because tangent, radius, they are at 90 degree, so this angle will be theta here. And if this is theta, which is opposite to OA in the triangle OPA, this will also be theta. Why? Because this is also radius and this is also radius. So two angles are theta, theta each. Okay. Now to find the area of APY in terms of radius, I can find AP. AP can be found using cosine rule, or you drop a perpendicular from origin to this, which will meet it at midpoint because it's a isosceles triangle, and call this as point M. So this AP will be equal to 2 times PM, and using trigonometry you can see it is 2a cos theta. Okay, and we know AP now. Now we can find AY also from this. AY will be actually AP into cos theta. AP into cos theta, because this angle is theta, so that will be 2a cos square theta. Okay, now this area which we are looking for, let's say A as a function of theta, will be 1 by 2 into AP, okay, into AY into sine of the angle that is included between them. So this AP is 2a cos theta, this is 2a cos square theta, so it will be 2a square into cos cube, I think, cos cube theta into sine theta. So we got the function, we just need to do the differentiation to know where we will have the maxima. Okay, this differentiation can be done. A dash theta will be equal to, I think, 2a square we can keep outside, then it will be cos raised to the power 4 theta. okay, minus 3 cos square theta into sin square theta. Okay, if we equate this to 0, I think cos square will go, I think tan square value will be equal to 1 by 3. Tan square value will be 1 by 3, which means theta will be equal to 30 degree. This means theta has to be equal to 30 degree. Okay, other than this, I think there will be roots when cos theta can be 0, cos theta can be 0, sin theta can be 0, no, not sin theta, only cos theta can be 0, and yeah, or tan theta can be equal to plus or minus 1 upon root 3. I think we will be taking only positive value because acute angle should be there, and we can check by either second derivative or change of sign of first derivative that at 1 upon root 3 it will be maxima point, it will be point of maxima. So where theta will be equal to, this will give you theta equal to 30 degree, and we are asked I think in terms of degree only, so answer for this question will be B. Okay, fine, moving to the next question, that is question number 8. Oh, I think this was 8. Now moving to the question number wait, this was written 8 only here. 7 we have done, yes, 7 was done, 8 is done. Now moving to the question number 9. We are given equation of an ellipse, or you may not think of as an ellipse. We are asked to find the maximum value of this mod of 2x plus 5. Very easy question, dear all. We can take x as 2 cos theta and y as 3 sin theta. Then we are looking for maximum value of this. We can write 2x as 4 cos theta and y as 3 sin theta. And in the trigonometry we have done that 4 cos theta plus 3 sin theta has maximum and minimum value as 5 and minus 5. Because there is a mod, so it will always be less than or equal to 5. So maximum value is B, 5. That's it. Now moving to the question number 10. We are given delta 1 as this, delta 2 as this, and we have to find the value of determinant. Okay, are they given determinants? Then we have to find the relation between derivative of delta 1 with delta 2. That is the question here. Okay, let's see how this can be done. There can be one method that you do the differentiation inside determinant, where you will have to, make 3 determinants. Like if you are going to if we are going to differentiate delta 1 with respect to x, okay, maybe what you can do, you can differentiate first row where you will get 2x here, and these 2 elements will be 0, 0, and other rows will be copied, a square x square b square and a square x square. Okay, likewise there will be differentiation in the second row where you will get 0, 2x b square. First 2 rows will be same, and likewise the third row in which you will be having 2 zeros here and 2x here. First 2 rows will be same. Now if you do this way, I think your derivative will be, now you can open it, we will be getting from first one 2x into x raised to the power 4 minus a square b square. From the second one, I think again if you open in the middle, I think I have done one mistake here. This is not b square, this is 0 here. So if you open along second row, okay, second row, first row, third row will remain same. So again you will be getting x raised to the power 4 minus a square b square. And from the third one also it is 2x here, and here also we will be getting x power 4 minus a square b square. Okay, so if I write this again, we will be getting I think 6x common, or maybe 6x common, x raised to the power 4 minus a square b square. Let us see if this can be compared with this value of delta 2 or not. 6x power 4, it is seen here. It will be 5x power 4 minus a square b square. So it doesn't seems like it is matching with delta 2 or delta 2 multiplied by 6. Okay, so maybe we should go for second time differentiation, and for second time differentiations definitely we will be differentiating this only, d square upon dx square of delta 1. So to do this differentiation, let's first multiply x with x power 4, so it will become x power 5, and do the differentiation of x power 5, so it will be 30 x raised to the power 4. minus 6a square b square. If I take 6 common, we get 5x raised to the power 4 minus a square b square. Okay, and you can check this is exactly the value of delta 2, 5x power 4 minus a square b square. So 6 times delta 2 will be the answer. 6 times delta 2 will be the answer. Let's see if it is matching or not. 6 times delta 2, so answer will be B here. Okay, moving to the next question, that is question number 11. We are given A, B and C, and we are asked trace of A, trace of ABC upon 2 and so on. Here please listen carefully, because BC is multiplied separately in every other terms like BC whole square, BC whole cube. So we should focus on finding the value of BC. Okay, how this can be done? I think simple matrix multiplication. B into C means first row, first column. So I think first element is coming out to be -1. Okay, then here I think it is coming out to be 0, 12 minus 12, and here also it is coming out to be 0, minus 6 plus 6. In this case I think it is again -1. So B into C is actually equal to minus I. So whenever you raise BC by even power, it will be I. If you raise BC by odd power like 3, it will be once again minus I, and so on. Okay, so whatever ABC, A into BC whole square by 4 they are, I think I can write this as trace of A plus, I think here it will be trace of minus A upon 2, because BC is minus I, plus trace of A upon 4, because BC square is I, and then minus plus trace of minus A upon 8, and so on. Okay, now trace of A is actually 3. So the trace of minus A by 2 will be minus 3 by 2, then it will be 3 by 4, then minus 3 by 8, and so on. So it is becoming a GP with common ratio minus half. Common ratio minus half. So this answer will be 3 upon 1 plus 1 by 2 gives you 2. So answer here should be 2. Let us see what is the answer given here. Yeah, 2 is the answer. Moving to the next question, question number 12. It's a question from inverse trigonometry, where we do questions of summation of tan inverse x, tan inverse y, and with the help of telescopic sum. Please see how this can be done. Here this expression given here is, let me write tan inverse. In the denominator I can write it as 1 plus 9r square common, r square minus 1. In the numerator I am writing 6r only. Now this can be written as tan inverse. In the numerator it is 1 plus 3r into 3r, and this is r plus 1, r minus 1. I am writing it as 3r into r plus 1 into 3r into r minus 1. Keeping one bracket here and keeping one bracket here. If you subtract these two, I think you get 6r, you can check. So this is 3r into r plus 1 minus 3r into r minus 1. So here we can split it as two tan inverses, difference of two tan inverses. One is tan inverse 3r into r plus 1, and another one is tan inverse 3r into r minus 1. So that was the important step. Now if this is summation s, the summation s sigma, so this s will be, if you write r is equal to 1 first, so it will become tan inverse 1 into 2 into 3, I think 6, and here it is tan inverse 0, you can check, because r minus 1 will give you 0. Then plus, if we put r is equal to 2, so 2 into 3 into 3, 2 into 3 into 3 is 18, I think, yeah. Minus tan inverse 6 will be here, you can check. Tan inverse 6 will be here. If you put 2 here, so it will be 6 here. And then next term, you can write tan inverse, if you put 3 here, 3 into 4, 3 into 3, 9, 9 into 4, 36. And then you can check tan inverse 18 here. In fact, I need not to write all such terms. I just need the last term when r is equal to 10 will be put. So when r is equal to 10, my first thing will become tan inverse 330. 10 into 11 into 3, yeah. And minus, if you put 10 here, it will be something, it doesn't matter actually, but you can write you can find this value also. Why I am saying doesn't matter, because this tan inverse 6 cancels, tan inverse 18 cancels, tan inverse 36 will cancel, and this will also cancel to its previous term. So what all we are left with is this tan inverse 0, that is 0 only. So we are left with tan inverse 330. Okay, so answer for this will be 330. Okay, now moving to the next question, that is 13. Yeah, we are given fx is equal to x into ln 1 plus x plus ln 1 minus x upon secant x minus cos x for x belongs to minus 1 comma 0, and this cubic for x belongs to 0 comma infinity. It is differentiable at x is equal to 0. We have to find the value of mod a plus b. Let us see how this can be done. Once again, to this function to be differentiable, first it should be continuous. So limit we will find x approaches to 0 minus. For left hand limit I will use this thing. So x into, we can write it as ln of 1 minus x square, and here if I take secant x common, it will be 1 minus cos square x, which I can write it as sine square x. You can check, if secant x is common, then it will be 1 minus cos square x, which is sine square x only. Okay, now if we do this calculation, limit x approaches to 0 minus x is here. In fact, let me write this as x square upon sine square x. I think there is a standard limit. We can write it as 1. So this x is multiplied with x extra x, and sine square is taken care of. And this ln of 1 minus x square also I am dividing by x square, so that this also becomes a standard limit. In fact, if it is minus x, then it will become 1. That's a standard limit. Now what we have done, please listen carefully, these two x square actually cancelling each other, so one extra x square should be coming outside, and one secant x is also there. So this will be 1, this will be 1, and this is 0. So answer is 0. So left limit is 1, 0. So if right hand limits to be 0, right hand limit should also be equal to 0, gives you b equal to 0. So we have found the value of b. Now it's a turn of finding the value of a. Now to find value of a, I need to find the LHD. LHD means it should be f of x minus f of 0, f of x minus f of 0 upon x, where limit x approaches to 0 minus, because we are looking for left hand derivative. For 0 minus we will use this formula, and for 0 I think the value is 0 only, then only this function can be continuous. We got the limit 0. Now here you can check, when we are finding this limit and we were finding that limit earlier, the only difference is that we are dividing this expression by x. So here there was one x, here you can check, okay, that will now cancel and everything else will be same. So our limit has to be equal to 1 here. Our limit here has to be 1. That means the derivative here will be, derivative LHD will be here 1, and RHD if you find, I think that's very easy to find. We just need to do the differentiation. It will be differentiate with respect to x and put x is equal to 0. So it will be equal to a. So from this we get a equal to 1. You may be thinking of that why we did the differentiation with the help of first principle. If you want to do this differentiation by proper differentiation using quotient rule, I think at 0 definition is changing, so it is not advisable, though I think in this case you get same result. But one more thing, that if you do the differentiation, it will be very lengthy, whereas I have concluded that LHD will be equal to 1 with the help of this limit only. Okay, that's why this LHD is 1, and we are getting a equal to 1. A is 1, b is 0. So I think answer is 1 only. Let's see what is the answer. Yeah, a is minus 1 they are getting. Okay, maybe I have done something wrong. Let me check. Okay, there was minus x square here. Yeah, there was minus x square here. So, but here it will not be seen because of it was becoming 0. But I think here it is 0. It is minus 1, sorry, minus 1. A is minus 1. So mod will be same thing. Answer is not changing, but the value of a was different. Now moving to the next question, that is 14. We are given fx equal to a times sine inverse 1 minus mod x upon 1 minus, it is not mod x, fractional part x. And similarly here denote the fractional part function, limit x approaches to 0 exists, then we have to find the a upon b GIF of a upon b. Now if we are looking for limit at x approaches to 0, take LHL. LHL means it will be limit x approaches to 0 minus fx, and it will be better that I write it that way, limit h approaches to 0, and here h is positive but very small quantity, and then it will be 0, it will be f of minus h, Okay, let me tell you this thing separately so that my calculation becomes a bit easier. Fractional part of minus h will be equal to 1 minus h, because h is a positive quantity, its greatest integer value will be 1. So if you greatest integer value will be minus 1, so if you subtract minus 1, so you will actually adding 1, so 1 minus h. In my RHL I will be needing this, that is fractional part of h, it will be equal to h only. Okay, let's use these two things, and then I think we will be able to do this question. Here it will be limit h approaches to 0, and sine inverse for minus h, if I put 1 minus, so it will be sine inverse h only, and in the denominator also h, and plus b times cos inverse h upon under root of 1 minus h. Okay, so this is a standard limit, it gives you 1 here plus cos inverse h approaching to 0 will be pi by 2, and here it is 1, so b into pi by 2, that is my left hand limit. I think I have missed this term a here, so it is not 1, it will be a here. Okay, likewise if I do for RHL, limit x approaches to 0 plus fx means limit h approaches to 0 f of plus h this time, and here if I put, my first thing will be 1 minus h, so I think I can write it directly a pi by 2. In the denominator it will be 1, so a into pi by 2. For the other one where limit h approaches to 0, it will be cos inverse, you can check cos inverse, if you put 1 minus h, yeah, it will be 1 minus h. In the denominator it will be under root of 1 minus h, or not under root, actually it is just it is under root, but it is just h here. Okay, so this becomes a into pi by 2, and to solve this thing, what we can do, we can either use L'Hospital rule, or we can convert cos inverse into sine inverse by using this thing, root over 1 minus h whole square upon h. Okay, now if you multiply and divide by the same thing, you will be getting this as a pi by 2 plus limit h approaches to 0, I will write it here. If I multiply by this under root sign in the denominator and numerator, sine inverse this upon this will become 1. Okay, so we will be left with this thing in the numerator, that is 2h minus h square upon h. I think it was root h, not h, it was root h, yes. So this will be equal to, let us do the calculation further here, a pi by 2 plus root 2 into b. I think I have missed b also here, into b. Let me check if everything is fine or not. Yeah, here it was b that I have not written, so here also b should be multiplied. Let us see the original question. Yeah, b is there. Okay, now we want this a plus b pi by 2 and this to be equal. Yeah, it is seen. Let me use this space here. So what we have found now, a plus b pi by 2 is one side limit, and a pi by 2 plus root 2b on the other side. Now I can take a into 1 minus pi by 2 here, and b into root 2 minus pi by 2 here, and we are looking for, I think, a upon b or b upon a upon b GIF. If I find a upon b here, Okay, it will be 2 root 2 minus pi upon 2 minus pi. I think they both are negative quantities. So let's write pi minus 2 root 2, yeah, upon pi minus 2. You can see they both are positive and they are less than 1. They are positive less than 1. So GIF has to be equal to 0. Why they are less than 1? Because quantity in the numerator is smaller, quantity in the denominator is bigger. So it is less than 1 and it's a positive. So it will be 0. So answer here should be 0. You can check. Okay. Now moving to the last question of this paper. We are asked to find the limit of this thing. Limit x approaches to 0, 1 plus x raised to the power cosecant x minus e upon x. Now in such question, what we need to do, we need to take log and in a special way. What is the speciality? Limit x approaches to 0, I will write this term as e raised to the power ln of 1 plus x raised to the power cosecant x minus e upon x. This is how we can write it. Now after this it will be limit x approaches to 0, e raised to the power ln of 1 plus x divided by sin x minus e upon x. Now if you check x approaches to 0, I think this limit will be 1, e power 1 minus e is 0, so this is 0 upon 0 form. Earlier also it was 0 upon 0 form. I think this is from the form 1 power infinity, this was e, and here it is in another form. Now what I will do next, I will be taking e common. I will be taking e common outside. So in this power it will become e raised to the power ln of 1 plus x upon sin x minus 1 minus 1 upon x. We can write like this. Now please listen carefully. This function that is on the in the power of e is now approaching to 0, because if you take the limit of this ln upon sin is 1, 1 minus 1 is 0. So using that standard limit, which standard limit I am talking about, e power x minus 1 upon x, when x approaches to 0, okay, when x approaches to 0, this becomes equal to 1. I'll use this, and now in place of x, I'll assume this function, so I will multiply by this in numerator, denominator and numerator, so that I can use that result. Limit x approaches to 0, e is outside, and for this entire bracket I am not writing what is there inside, but I am writing what I am dividing by limit ln 1 plus x upon sin x minus 1 is what I am dividing with, and then I have to multiply by the same thing, ln 1 plus x upon sin x minus 1, and I am putting x here. Okay, why I have did so? Because this bracket I have written it here. Now you can check e power fx minus 1 upon fx, where fx is tending to 1, so this thing will become equal to 1. Okay, so I will not write this anymore. I will be having now just e, let me write it here, limit x approaches to 0, e here, okay, and this will be equal to 1, and then we will be finding the limit of this ln 1 plus x minus sin x upon x sin x. Okay, similar to what I did here, if we multiply by x in numerator and denominator, sin x can be removed and it will be just x square. Okay, so here we can write this as limit x approaches to 0, e outside, and in the numerator it will be x square, and we can expand ln 1 plus x, that is x minus x square by 2, just 2 terms are needed, minus for sin x it will be x minus x cube upon 3 factorial, that is 6 you can write, and in the denominator it is just x square. Now this x term is getting cancelled, x cube is not needed because we are having x square here, so this limit will become equal to minus e by 2. See, when x square will divide x square, here we will get minus half, when x square divides x cube, we are getting x here which is tending to 0, so we can neglect it. So minus e by 2 will be the limit. And what we are asked that if it is equal to minus p upon q into e, where p and q are natural number, then we have to find the minimum value of p plus q. So answer is 3. Okay, because if minimum value means they should be in their lowest form, so answer will be 3. So this is how this question is solved. I think this completes the solutioning of this paper. Okay, thank you so much. I'll come again with paper 3 very soon. Bye all of you.